The entire field of language education is built on a false premise. The premise is that a language is something you learn. It isn't. A language is something your brain grows, and you cannot learn your way into growth. You can only create the conditions for it, and most people never do, because nobody told them what those conditions actually are. I want you to sit with that for a second, because I know what you're thinking. You're thinking, well, learning and growing, aren't those the same thing? And the answer is no. They are profoundly, mechanistically different. Learning is what happens when you consciously acquire information and store it in explicit memory, the same system you use to memorize a phone number, or remember that the Battle of Hastings was 1066, or recall that the French word for apple is pomme. Growth is what happens when your brain rewires itself below the level of conscious access, when new circuits form, when dendrites branch, when synaptic connections strengthen through repetition until a process that once required effort becomes automatic and invisible. Those are not the same thing. And the tragedy of language education, from kindergarten classrooms to the most expensive Rosetta Stone subscription you've ever bought, is that it keeps trying to use the first mechanism to produce the second. That is not a small error. That is like trying to build muscle by reading about weightlifting. You can memorize every biomechanics textbook ever written. You can describe in precise anatomical detail exactly which fibers fire during a deadlift. You will still be weak, because knowledge about a physical process and the physical process itself are not the same category of thing. And your brain's relationship to language is far more similar to muscle growth than it is to memorizing facts. It is a biological process. It has biological requirements. And if you do not meet those requirements, nothing happens. It does not matter how hard you try. So let's talk about what those requirements actually are. Not the ones the apps tell you about, not the ones the classroom curriculum was designed around, the actual neurological requirements rooted in what we now understand about how the brain acquires complex procedural and pattern recognition systems. Because here is where it gets strange, and I mean that literally. The mechanism by which your brain acquires a language is not fundamentally different from the mechanism by which it acquires the ability to recognize faces, or to catch a ball, or to walk without thinking about walking. And the moment you understand that, everything about how you should be spending those 20 minutes changes completely. Let me start from the bottom. From the actual substrate, your brain contains roughly 86 billion neurons. Each of those neurons can form thousands of connections with other neurons. The total number of possible connection patterns in a single human brain exceeds the number of atoms in the observable universe. I am not being poetic. That is a real number. And what that means is that your brain is not a storage device with limited capacity. It is a pattern recognition and pattern generation machine of effectively unlimited complexity. When you learn a language, when you truly acquire it, not when you memorize it, but when you grow it, what you are doing is carving out a particular region of that astronomical connection space and making it habitual. You are training a specific subset of circuits to fire in specific sequences with specific timing until those sequences become as automatic as recognizing your own name. Now, here is the critical question. How does that carving happen? What is the mechanism? And this is where the science becomes genuinely surprising, because the answer has nothing to do with conscious effort in the way most people imagine it. The answer has everything to do with input, specifically comprehensible input delivered at a rate and density that keeps your brain in a very specific neurological state. A state that researchers have spent decades trying to characterize, and that a linguist named Stephen Krashen spent most of his career pointing at, often while being ignored by the mainstream of language education, the way people who are right too early usually are. Krashen's hypothesis, and I want to be careful with that word, because it is not just a guess, it is a formalized, predictive framework Krashen's hypothesis is that language acquisition happens through one mechanism and one mechanism only, comprehensible input, meaning exposure to the target language at a level of complexity slightly above what you can currently fully understand, delivered in sufficient quantity under conditions where your guard is down. That last part is important and we will come back to it, but the core idea is this. You do not acquire language by studying it. You acquire it by being bathed in it at the right level for long enough that your brain begins to unconsciously extract the statistical regularities of the system. I want you to understand what that word unconsciously actually means here, because I think people hear it and think it means passively. It does not mean passively. Your brain is doing something extraordinarily sophisticated when it is processing a language. It is in the process of acquiring. It is performing something analogous to what statisticians call Bayesian inference. It is continuously updating an internal probabilistic model of the language based on every piece of input it receives. Every time you hear a sentence and understand even part of it, your brain is silently revising its estimates of what patterns are possible in this system, what sequences are probable, what structures are legal, and it is doing this without your awareness, without your permission, almost. Your job is not to direct this process. Your job is to feed it the right raw material and then get out of the way. And here is where it gets strange, genuinely strange, because Krashen also proposed something called the affective filter hypothesis, which sounds like soft psychology.